Hi, my name is Raglan, and this video is going to be on a capstone project and what I have accomplished this semester in regards to the project. The topic of our group's project was building user communities. I will first be briefly going over the project outline. The objective of our capstone project was to find like-minded user communities based on social networks. This is important when it comes down to applications such as news recommendation, user prediction, and community detection. This information can be useful when sites try to target ads or products or even other articles towards specific groups. By being able to better detect user communities, it is much easier to send relevant information to people which they might end up being interested in or they may end up viewing. There are two main approaches when trying to find like-minded user communities. One is topology-based while the other is topic-based. For topology-based, the user's social network connections are taken into account, so who they are directly connected with. However, this does not necessarily provide the best results, as people who are connected don't always necessarily have similar interests. They can be connected just because they are friends or family or relatives, and that does not necessarily mean they have similar interests or opinions. The other approach is topic-based approach. This approach takes into account a user's content, so their posts are taken into account in order to determine their interests and opinions. This seems to be a much more reliable approach than just looking at connections. However, there is still an issue when it comes to this. People may be interested in topics at different times. For example, I may be interested in topic A in the beginning of the month and lose interest in it by the end of the month, while another user may just gain interest in the topic in the beginning of the following month. This method of finding user communities would still group us together. This is, however, inaccurate, and as a result, for an ad example, some users may get informational products that they are no longer interested in. For that reason, we must take into account temporality as well. We must determine like-minded user communities based on topics of interest over time intervals. This way, people interested in topics during the same time will be grouped together. The use of neural embeddings to do this is one of the goals as well. For this project, we will mainly be focusing on Twitter data, even though the concepts are applicable to other social media platforms as well. The reason Twitter data is chosen is because of the ease of accessibility of these datasets online. I will now go over the tasks that were accomplished throughout the course of this semester and the tools that were used. One of the first things that was done this semester was to read a couple of research papers on similar projects to get a basis and general understanding of the steps to be taken. The project can be divided into two main parts, one being topic detection and the other being user community detection. This semester topic detection was focused on. For this, an article on LDA was read through. LDA is a probabilistic model, a collection of documents made up of parts. In our case, the parts are words and the documents are tweets. There are two main probability tables, one being the chance of selecting a particular part in a topic, and the other being the chance of finding a particular topic in a document. There was an online Jensen tutorial regarding LDA that was written in Python. This was tested out using Twitter data. Twitter data was gotten from an online archive. The data was then pre-processed, removing stop words, as they have no use when trying to determine topics. Non-English words were also removed from tweets, using the LangDetect library from Python. Lemmatization of words were also done, in order to get the base form of each word. These steps were initially done to remove all unnecessary information from the text of the tweets. Initially, a lot of data was not able to be run due to laptop performance. The number of topics for this LDA algorithm was experimented with in order to determine which number of topics would produce the best results. Only a couple of thousand tweets were able to be run due to laptop specs and the amount of time it would take. For example, around 2,000 tweets took around half an hour on my laptop. As a result, the visualization of the LDA when using the matplotlib was not that great. The tutorial also mentioned another LDA model, which is the mallet LDA model. There were issues initially getting this set up on Windows, but after working with path and environment variables, it ended up being solved. The same issue of non-coherent topics was observed due to the number of tweets that were used. Due to this ongoing issue of numbered tweets, some research was done by a group, and we decided to set up a Google Cloud trial with free credits so that a virtual machine could be used to perform this analysis. The virtual machine with 30 gigs of RAM and 8 cores was set up. The LDA was then performed again using multi-core version of the regular GenSim LDA. It performed much faster than on our laptops. Topics were more coherent as well. So after the LDA, for each tweet, the top 3 dominant topics were found. Tweets were then compared pairwise. For every tweet, if they had one matching top 3 dominant topic, cosine similarity was calculated. This was done in order to determine how similar the documents were. A word-to-vec model was trained using GenSim. A word-to-vec model is a word embedding model used to predict words based on a corpus. The technique that was used was a continuous bag of words, which looks at n words before the target and n words after the target to make a prediction. Every word in the tweet was compared to every other word in the other tweet, and the sum of all cosine similarities and the average was then taken. This was then plotted on the network X graph, which is another Python library, where each tweet was a node, and the value of the edge was the average cosine similarity. We are currently in the process of chaining up the algorithm so that each tweet is one vector, and one cosine similarity is calculated instead of n times m cosine similarities. So that's currently in progress. Also, a general clustering algorithm was performed using network X, which displayed which cluster each node belonged to. Now I'll be briefly going over how we collaborated as a team throughout the course of the semester. We had created a Slack channel where we'd post any questions any of us had. We would also post any helpful snippets of code with Python commands, as well as any other useful articles that we found. We also met up a few times to work on the project as a team. One time we initially met up to set up the Google Cloud instance in the VM. We were initially having trouble with setting up the Jupyter notebook on the VM, but later found out it was only due to itinerary restrictions at the library, as it worked later when we tested it at home. We also met a couple of times to get the entire process of topic detection working on one account on the VM, as when we were individually doing it, most of us had general issues, so we decided to work on it together. Lastly, I will go over our plans for the future. One of the plans is to have few months worth of tweets run over the winter break and pre-process the data and save it. This is because we found the pre-processing step to be one of the most time-consuming steps. So whenever our PC will go to sleep, the VM will disconnect and stop executing. So during the break, we just plan on letting it run and pre-process, save the data into like a text file or JSON file, so that this step can be skipped in the future. For next semester, we plan on working on the user community detection portion while taking into account temporality. So the creation time of the tweets will need to be considered for this part. We also need to go over the multivariate time series approach of building user communities and put everything from this semester and next semester together. So that's basically an overview of what was worked on for the capstone this semester. Thanks for listening.